Good afternoon, everybody, and welcome to this second of the Circular Cities conversations that we've held. The other one was a couple of months ago, and our hosts the Hapold Foundation, will give us a little bit of a background on that and how that all worked. My name's Andrew Scoons. I'm from Engenuity, and we organise these in association with the Hapold Foundation. And I'm just going to tell you a few admin things. We are recording, which I hope you were told on entry. So just be aware that that's something that we'll publish, and you can tell your friends about and other people if they failed to get there. We would ask you if you stayed on mute, but do unmute yourself when you're invited to ask questions, make comments, or whatever you'd like on that. You are very welcome to switch on your camera. We're in meeting mode, not webinar mode, because we find that more sociable, where you can see people's faces and you get a nice feel of not just people behind their blank names on screen, so that's very nice. It is intended to be a conversation, so although we've got some very eminent contributors to stir up the conversation, please feel free to drop comments, questions, anything you like in terms of information. We get huge amounts of links on LinkedIn, on the internet and things like that from people participating. Put them in the chat and we'll draw you in through our two fantastic chairs who come back for a second time from the Circular Cities theme, Annika Buchmeier and Kitty Walker. Kitty's going to say a few things first, I think, about the Hapold Foundation and their activities as a whole before we get stuck into the subject. Thanks very much.
Thanks, Andrew. Actually, Annika's going to start us off and then we'll continue on with our panelists.
Thank you. Yeah, first of all, we want to welcome all of you for joining the discussion today. We are very delighted to be chairing today's conversation about circular cities. And as Andrew already said, it's our second time we are doing this. Yeah, basically, Andrew already said most things about the housekeeping. We want to have an open and collaborate, respectful environment here. So we prepared some questions to the panelists as a start, and then we would ask everyone to post some questions in the chat maybe first, and then we will invite you to join the conversation later on. The Hapold Foundation is our host basically today, and therefore we also want to introduce it quickly. The foundation is a charity dedicated to inspiring engineering and using engineering skills to make a positive impact on people's lives and to improve the built environment, creating a more inclusive future. The foundation has about 4 key focus areas, which are the human development, futures, education, and also thinking. And the city conversation is part of the thinking focus area. Yeah, thank you again to the Hapold Foundation for letting us host today's conversation. We are Kitty Walker and Annika Buchmeier. Both of us are working at Buro Hapold. Kitty is a facades engineer and I'm a sustainability consultant. And we are collaborating on a research project, which is an internal Buro Hapold project around circular initiatives and circular cities. We are very passionate about that field, and that's why we are hosting these conversations. As a quick recap, some of you might have, I'm sorry, the presentation is having a bit of an issue. I hope now it's fine. So some of you might have heard all of this before, as we hosted the Circular Cities panel discussion back in February, which focused a bit more on city-wide policies. And the panel conversation we had there looked more on regulatory frameworks on national and city strategies, alongside with some inspirational design ideas and strategy cases from different scales. We had some really amazing panelists representing the cities across Europe and also Africa, and people from the UK were joining, and had some fruitful discussions about the topic, and which was very encouraging to host another conversation together with the Happold Foundation. Yeah, we felt like we want to delve a bit deeper into the specifics of material reuse. And our first discussion basically ended on the provocation of like build nothing, and caught a flurry of discussions and questions coming up on this. So this is basically the main reason why we want to get a bit more insights on the topic of material flows, material mapping, and urban mining. And we also have a problem statement, which is Kitty going to lead you through.
So just to set the scene a little on the problem. So as probably most of you know, the built environment and the construction sector is by far the largest emitter of greenhouse gases, accounting for a staggering 37% of global emissions. And as cities only cover 3% of the world's land surface, but house 80% of the population, they rely on massive amounts of physical, chemical, and biological resources to support this growth, which we feel makes them catalysts for change. We're extracting materials at an ever-increasing rate and knocking down buildings which are not past their end of life. And then even once we do knock them down, they house plenty of resources which we could utilise and mine from our urban environments. We feel that greater material efficiency could save most of these emissions. And as cities are responsible for 35% of the EU's total waste generation, this feels like the place to focus our efforts. The circular city model emphasises efficient material cycles, the use of renewable energy, and at the same time, preservation of biodiversity, promotion of culture, and prioritisation of health. At the moment, our global economy is only a shocking 7.2% circular, so there's plenty of room for improvement here. Next slide, please. However, we are seeing some shifts in the industry, with material salvaging becoming ever increasing and recycled material development progressing. Some bricks made out of old recycled plastic and bricks made from waste within the construction sector, and some interesting projects using reused material, which I'm sure we'll hear more about later. So this is why we wanted to explore further material flows, identify potentials in material mapping, and understand more the potentials for mining our Anthropocene. And therefore, we've invited 5 fantastic panelists, as they're all experts in the industry, and we're super excited to delve deeper into the issues at hand with. So we're going to start off with Nico Schulten, who is the team lead of the built environment team at Metabolic, where he helps governments, architects, and developers make their projects more sustainable through circular principles and systems thinking. Metabolic is a consulting and venture building company that uses systems thinking to tackle global sustainability challenges. So yeah, over to you, Nico.
Yeah, thank you very much for having me today. Let me share my screen. Today I'm going to talk a bit about some of the recent research work that we've been doing at Metabolic. As Kitty already told, I'm part of the consulting branch of Metabolic, where my team specifically focuses on the built environment. And we do research on circularity through all layers, all the way from individual buildings to European construction sector scale. And that is what I want to talk to you about today. So we all understand, and Kitty explained just now, that the built environment is a major environmental driver. And when we look at the annual consumption the European construction sector has, we can see that we roughly consume 1 million kilotons of material. That's quite a bit. That's enough to construct 185 permits for ESA every year. And to bring that a bit more into perspective, we've done a very elaborate analysis on what types of materials we are using in what part of Europe. We visualize this in this material flow analysis, where on the left you can see what materials we are using. So you can see a significant part, the majority of the materials we're using is reinforced concrete. Then where are we using these materials? We can see Western Europe is quite an impactful region, considering that it's housing a big part of the European population, but also consuming a large part of our resources from a built environment perspective. And then here on the right, you can see where we are actually using this material. So you can see a big part of our material consumption is in residential housing. We're also throwing a lot of materials away. So the European construction sector on annual basis throws away 124 megatons of material. That's enough to construct a tiny house for every inhabitant of Austria and Hungary every year, just considering the waste that we are producing. And to again have a better understanding what types of materials we're wasting and where we're wasting it, we see that again, Western Europe is a very big waster of these resources. We demolish, even compared to our inhabitants, much more than other parts of Europe. And then again, concrete is a very big resource flow. When we look at where these materials are going, we can see that the vast majority, 70% of all the waste becoming available through demolition activities is currently being backfilled or recycled. And that the circularity of the high value reuse of these materials are currently not even known or very, very limited. This is causing a lot of CO2 emissions. So all this material consumption, if we keep building this way, we will consume or emit roughly 7 gigatons of CO2 emissions until 2050. And that's, of course, a very big problem because it will mean that we cross our planetary boundaries. A very famous planetary boundary is the climate change boundary, where we know that if we cross the 1.5 degrees scenario that we also agreed on in Paris, if we want to remain within, we might actually have some very serious problems. And if we keep constructing the way that we're constructing now, we can see that we will cross, as a European construction sector, this budget or this boundary in 2026. The 1.7 degree follows very quickly after, and then if we don't change anything, we will cross the 2 degree scenario in 2033. So that's quite an alarming image. And to better understand how we could deal with this environmental impact, we've been modeling 9 different interventions. So this is a very broad, from transformation of existing buildings to design for disassembly, building with bio-based materials, and also the recycling and the reusing of building components. And since that's very relevant for today's topic, I want to dive a bit deeper into what this reuse of materials actually could look like when you take it back to the city scale. So to talk a bit about cities and urban mining. When we talk about the urban mine, it's a very well-known concept, but we see really the buildings that we've constructed over the past centuries as mines for future reuse. But to do that, we need to think about a scale that reuse is valuable and even possible. And to gain a bit better understanding, we've mapped the city. So this is a material flow analysis of Rotterdam, a city in the Netherlands, where on the left you can see all the materials flowing into the city. So energy, food, consumption goods, but also construction materials. And then on the right side, all the materials that become available on an annual basis. So a lot of organic waste, and also on the right, of course, what's currently happening. For the construction materials, we currently see that there's a lot of downside, which is very similar to the European picture that I just painted. How we map this material flow is really having a look at and the potential of this reuse is by looking at the construction and demolition plan of the city of Rotterdam. So what you see here is a map with all the construction plans, which are green, and then all the demolition plans, which are red. And when we just very quickly compare those two and try to match supply and demand, we can see that until 2030, there's only 229 demolition projects. But there's over 4,000 new construction projects with 250,000 square meters of gross floor area being demolished, but over 5 million square meters of gross floor area being constructed. This is already a very clear indication that even if we reused all the materials becoming available through demolition activities, we will never have enough to replace the virgin material demand if we want to, of course, also house or construct the housing that we need from a social perspective. This analysis also really allowed us to really make a very clear spatial and time analysis of when materials would become available, because as we are still in a linear economy, we kind of have to catch these resource flows before they are lost to the linear system. And what we saw is that actually it does really matter when you harvest these materials or when you have this infrastructure available to close these reuse loops. So in 2020 and between 2020 and 2021, there's a very big increase in materials becoming available. And then 2022 and 23, again, a big leap. And this insight really helped our clients, which were the municipality of Rotterdam, to understand that they really needed to make haste if they wanted to capture all these valuable resources before they were being downcycled or landfilled. What this analysis also focused on is that circularity is not a goal in itself. We don't have to just reuse materials. We reuse materials to reduce the environmental impact of our construction sector. And what we show here in this analysis is that if you compare the mass of the resource flows becoming available in the city of Rotterdam, environmental impact and the cost gain that you could have through reusing these resources, we can very clearly see that if we want to prioritize the environmental impact, some very important decisions have to be made. For instance, here you can see insulation materials, which is a very limited mass, has a very high environmental impact, but has a very poor business case. On the right, we also visualize how certain hurdles would make the reuse of these materials harder. So it's about standard sizing, risk for pollution, or the warranties for good functioning of that. But really understanding these resources and also understanding what these resource flows could look like, we then map those flows through the industrial process and profile of the city of Rotterdam to understand that maybe if you want to reuse concrete at a large scale, you really need an industrial plant where these resources could be cycled and repaired or even recycled, which might not happen very much within the city. For other resource flows, such as doors or windows, the reuse or recycle process looks a lot easier. And then making a more localized chain actually really helps by also creating a healthy city, a vibrant city, and also a city in which there's jobs for a larger audience. So this is a very large overscale view of what circularity or the material consumption from a European perspective looks like. We also looked at what happens if we apply circular principles to the built environment on a city scale, but what happens if we then again scale this. So when we scale all the 9 interventions that I mentioned at the beginning, so looking a bit broader than just circularity and circular material use, we can see that we can actually very much bend the curve down. Through decarbonization of industry and applying this broad range of circularity scenarios or interventions, we can reduce the environmental impact of the construction sector by 70% in 2025, and also push the deadline that we're crossing the 2-degree scenario by roughly 10 years, which means that we really buy ourselves some time to focus on further innovation and really applying the best of our skills to get a construction sector that is within.
That was super interesting. Thank you. It was really nice seeing all those maps and I feel like you could delve so deep into all of them. But I just wanted to quickly ask you before we move on. We've spoken to a lot of people and they've said that finding the right data and putting it to use is a massive challenge. And did you find that when you were making the maps on Rotterdam?
Yeah, so there is a very big challenge, but what we did with these maps of Rotterdam is that we've used a large database with reference buildings, which could give a first insight into the potential of these demolition plans. But then reusing these products and actually harvesting them does ask a lot of on-site scoping and scouting of materials and also repairing them. So the work that we're doing is very much at the beginning of the process to show different stakeholders, so both public and private parties, the potential that lies before them, but then really getting on the ground and doing them does ask, of course, a lot more work and innovation.
Great, thank you. So now we're going to pass on to Andrea Chalson. So Andrea is the Managing Director for Madasta UK. She's now bringing material passports to the UK to transform how we value buildings and materials through the use of reclaimed materials and designing through to facilitate future reuse. Madasta is an online registry for materials and products, and on Madasta, data is recorded on all materials and products that can be incorporated into future real estate. So over to you, Andrea.
Thank you very much. Yeah, without further ado, I'm going to actually just start talking about what Medasta is, because it's all to do with this materials mapping and mining topic. So Medasta is a material cadastre, a cadastre being an official registry of the ownership of property, and Medasta being a register of the materials and products that are within our built environment. So to make that come to life, I'm going to talk you through a little bit of how Medasta works and what that means. So everything in Medasta starts by recording detailed information on each product or material, also known as a product level passport. So we try to record wherever possible what the product is, who made it, where it was made, its embodied environmental impacts, its circularity attributes, and then anything else that would be useful to pass on to the supply chain throughout the life of that product. So this could be certifications, warranties, technical specifications, cleaning and maintenance schedules, or even information about take back and buyback schemes. What we then do is combine that with information provided either by the design or the construction team to create a full record of the materials and products that are contained within an asset, creating what is commonly referred to as material passports for buildings or for assets. And so what you've got then is a full record of everything that has gone into your building, and then links to much more detailed information about those products and materials. Once we've got all that information, we can then start to unlock a whole range of environmental impacts and insights, such as what materials are located within the building or the asset and where are they. We can start to explore the circularity, and so that can be both what I like to call its circular history. So are those products already recycled or reused? And also its circular future or potential circular future. So are they available for recovery, and can they then be reused or recycled once recovered? We can also use the same information to assess like a whole range of environmental impacts, so such as the whole life carbon of both the materials and therefore the assets that are created from the materials. So once we've got that information, as well as having like the repository of the data itself, we can start to calculate KPIs for the whole asset. And this can be useful to support building level reporting requirements, such as those in like green building rating schemes or planning requirements. But most interestingly for the topic of today, and touching on what Kitty was just asking and what Nico was describing, the information on the individual assets can then be aggregated across either a portfolio of assets owned by a private entity or even a public entity, or even across a geographical region. And so this is an example here where we created asset level records for all the buildings within this village, which is a subset of Heidelberg. And then we can start to unlock some of the insights that Nico was just describing, sort of what materials are in those buildings, where are they, what's their circularity potential, when they become available. And so that's kind of like the kind of mechanism of what we try to do, or what we try to facilitate through the platform. But why do we do all that is probably quite an important question as well. And the reason we do that is to provide both the data and information to support a wide range of needs. And some of that data and information helps support like data-driven decision making, so to actually change what happens. And some of that, it's just to facilitate kind of an easy and efficient route to reporting. The type of needs that our users are interested are quite varied. So we are established like with the idea of promoting a circular economy, and so that the idea of having this information available at all the various levels, so product and asset and portfolio or region, can help promote a circular economy in lots of different ways. The fact that we can kind of make that information available throughout the design and construction phase means that it can also be used to then inform decisions about those design and construction processes. So you might want to choose to design something in a slightly different way or choose a slightly different specification of material or product. Very specifically in London, this kind of information can help support planning requirements, both in terms of like the KPIs themselves, but also the act of creating the passport and creating that record of what's in your building. And then kind of moving more towards the asset and also the portfolio level, collating this kind of information can help streamline ESG reporting, particularly with the requirements that are coming down from Europe through the EU taxonomy and CSRD. But it can also help unlock value, and whether that's unlock the value that's like within the product itself, because it's either able to go back to the manufacturer or be sold on the market, or whether that's the value of the asset as a whole because it's got much more robust evidence about the materials that are within it, which links also to the risk reduction. Again, there's been a few too many unfortunate incidences where material issues have kind of led to significant impacts at an asset level. And by having this information available, you're kind of much more easy to assess your exposure to any of these kind of potential risks. And then I just wanted to finish my introduction with this quote from the Deputy Mayor of Heidelberg, which was him talking about why they decided to create that register for the buildings that were in the city. And he said that in the future, this register will help show them what materials have been installed in the city, in what quality and quantity. They will then be able to use this information to inform strategic decisions such as planning deposit sites and processing areas, and therefore promoting regional value creation and regional supply chains and new business models, ultimately reducing their dependence on imported raw materials and long transport routes. So quite a lot of different value propositions in there, combining both the environmental and the kind of socio-economic with the kind of local supply chains and business models. And that's what I wanted to do to start. I'll stop sharing.
Amazing, thank you. That was super interesting. I was also just wondering, how could we as engineers and consultants help progress material passport use in the way that we're recording data in our design process?
So one of the things we've been trying to do with the Medasta platform is make it as easy and as efficient as possible to create this passport, these passport records. So one of the ways that we can generate that asset level record is just by taking the BIM information, if the project's been designed in BIM, or it could be taken from like a bill of materials. And then all we actually need is like the quantity and a description of that product or material, and all the rest of the detailed information is recorded elsewhere in the system. So it's kind of trying to reduce the burden on all of the design teams of having to gather all of that information individually, and just kind of doing that in quite an automated way. And I think kind of very specifically on what you guys can do, it's kind of highlighting to the people that you're working with, whether it's like your clients or your design team collaborators or the material manufacturers, that why you think capturing this information in this way would be useful, and whether it be useful for you now during the design process, or whether it's going to be useful adding value throughout the life of the asset. Yeah,
for sure. I think everyone needs to be more aware of how down the line these things can be more important. Thank you, Andrea. Perfect. So we'll move on to Jose Pepe Taveras. Pepe is the co-founder and CEO of Supply, a circular software platform based on digital twins and AI-enabled workflow automations aiming to create zero waste communities. Pepe is a sustainability entrepreneur passionate about using technology to create impact. Pepe has a background as a mechanical engineer and experience in the field of material flows and automation and circularity. Yeah.
Good afternoon, all of you. I'm here calling from Denmark. While I present my screen, let me just say thank you so much for hosting us here. So I will just give a very brief introduction of what we are working on. Just wanted to confirm you can see my slides moving and then coming back. Yeah. Well, thank you so much for the introduction as well. So yeah, I am the co-founder and CEO of Supply. What our purpose is that we want to make this circularity happen. We believe that if we actually accelerate the shift towards circularity with a very good tech, going all the way from what we call mapping or digital twinning, all the way to reporting in the value loop, it's actually going to accelerate this transition. Why I insist in the accelerate part, it's because today, what we have seen that the circular economy or doing circular models or circular practices within the built environment can be up to 3 times more expensive and 3 times less efficient. In very short, what does it mean? Companies right now, all the way from portfolio level to product, if they want to do some sort of circular economy thingy, it's more expensive, and that's why it's not very widely adopted today. Why is that? Because there is definitely in one side a lot of challenges, but in the other side, there is also a lot of additional requirements. So I think it's a very simple business proposition. If circular economy, if there is more cost associated for circular economy, then there is definitely less engineering, less data, and ultimately less circularity. Again, I see that this is not very widely adopted, at least here in Europe. Actually, the data that we have seen more practical into the ground level is that less than 1% of resources follow any type of, let's say, circularity. And I don't mean circularity as in the end when it gets taken back or when it's resold or reused. I mean even less than 1% today, it's getting mapped. So this is some sort of alarming, but I think when we balance this impact-driven but also business-driven situation, it's why we are not reaching that scale. What in the other side of the spectrum, and that's what we have been seeing, it's that the data requirements or the engineering design requirements for circularity to happen are actually trivial. They're not so crazy requirements. However, there is a lot of data around them. So to answer these very basic questions is what's inside our buildings, what's their worth today, in the future, and what is their CO2 through their life cycle, but also their cost through their life cycle. It's questions that are still a little bit up in the air that, at least in Supply, we are trying to solve. Once you add on top of that the layers of, okay, now I know what I have, now I know what is worth, then how can I actually circulate them? On top of that, the regulatory requirements on reporting, they are insane. There is a lot. The people here in the ground don't really know how to report this. It's something new for all of us. So all of this together is just what we call added costs, which added cost, again, equals to low circularity or low execution of actually some sort of circularity practices or models. Let's just put it in perspective, diving deeper into the resource mapping here in Denmark, but it's similar in the UK, in Germany, in other parts of Europe. Resource mapping, which is basically getting to know what's in the building, can cost easily 20,000 euros. And it's a process that can take 2 to 3 weeks just to have a detailed data on what you have. And this, it sounds like not a lot, but when you put it in perspective, the cost of circularity, it's very big compared to business as usual. Actually, think about it. You spend 20,000 for 1,000 meters, which is nothing, and you get some report looking like this, which is basically telling you here we have X and there we have Y. There is some testing, etc. But that's what people are working today. Very low digitalization, but also very low connectivity. And that is just, let's call it the first step towards mining. You need to know what you have. Still, there's a lot of many other requirements that, again, are costs, are time, because what we have seen is that all these circular efforts or circular requirements are being taken by manual manual ways right now. A lot of Excels, a lot of exchange data through emails. There is not like a material passport that everybody can access or dig into. It's more exchanging information through emails. Data banks are very similar looking like reservation systems. And this is just simply very time consuming and expensive. That's what the monster we are facing. But we have tried to fix this by streamlining every requirement needed to go what we call from resource mapping to actual circularity of resources and reporting, but also from portfolio to product level. And that is what it's very interesting for us, because this is how actually our platform works. So we start by creating digital twins on the portfolio level of buildings. So meaning no more or less what would be in there. We use a lot of models that we have created to actually fill the data blanks on portfolio building product level. And that gives us the resources to be ready for circularity, what we call them. So once you have the full data, now you can establish a proper take-back scheme, a proper reuse methodology strategy, a re-commerce, etc. Finally, we go to reporting. That's the loop that we've been working on, but we try to do it as automated as possible. We've been told that we are one of the few ones that do not need to go to the site to actually be mapping. We try to map based on really, I would say, good assumptions of how the portfolio of it will look like in terms of resources. You can actually see it here, that this is just a screenshot of our product. How we go from, let's say, the portfolio level. This is a full district of buildings that is going to be reused here in Denmark. Then that gives us the possibility to link standard grade tools as 3D models, our databases, drawings, whatever information, you basically dump it into the platform. And that gives us a very detailed resource mapping, so detailed that we know not only the product level, but the composition, cost, carbon, anything that you can think of that it's needed in a material passport. We are able to get it because we use a lot of AI to do so. We are so excited of what we are building that we actually have proven to give this data widely available. We actually have like an embedded engine that anybody can access and ask any question about the material passport or the portfolio level. So right now there is no more exchange of handing over the material passport, let's say. So right now everybody can access and collaborating within the same platform, which is a difficulty that we've been seeing when you are talking again of circular flows. It has been so interesting, and we have had so much knowledge, or we have gathered so much data, that right now we are not doing digital twins only for existing buildings to be demolished or renovating, but everything that gets new built or the new renovation, it's digitized and stay in our digital twin, because now that allows to future circular flows, such as product as a service, design for circularity. We actually are doing it already, where companies are doing their full circular operations with our platform, but instead of starting from a mapping, starting from the moment they produce or manufacture the products all the way to the take-back. And that has proven to reduce the cost, makes circular economy in building products competitive. We actually have proven by the most important companies here in Denmark and also in other places in Europe to say that actually they are going 4 times faster and affordable the circular economy. So meaning we're almost there in terms of competition as business as usual. And the impact is there. Once you make it competitive business-wise, we have proven that we can reduce up to 1/4 of the waste that would be generated. And that is just awesome. We are actually making circularity happen. Thank you very much. Before I conclude, companies in the portfolio level, like Ikeno, this is the IKEA real estate developer, are actually telling us the same, if you go from portfolio to product data-wise, you can actually make it efficiently, circular economy, and that's what we've been trying to do. Thank you very much, and that's all for me.
Thank you, Pepe. That was great. Super interesting to hear what you're doing. Just similar to what I was asking the others about with the data, how do you ensure the accurate data? I know you're making assumptions, but are you partnering with architects or part of the design team? How is that coming to you?
Yes, actually, our tool is very operative. Like it doesn't work as in one click you do everything. Actually, the stakeholders of the project's portfolios, like designers, consultants, are in the platform, using it to streamline their own processes of calculations. So all data is, yes, assumed, as in digital twin, but I would go more than assume, aggregated. It's aggregated by whatever the consultant put in, whatever it's in the databases, EPDs, etc., whatever the engineer puts in, that we just put it together in this digital twin, and then we use it for the benefit of all. Not so much that we assume data, but more that we aggregate what was scattered these days. Yeah.
So we're going to pass over to Dr. Colin Rose now. So Colin Rose is an architect, senior research fellow and industrial tutor at UCL and a founding partner of UKCLT. His work focuses on bringing about a more resourceful and circular construction industry. So as a founder of UKCLT, which won a Waste Build Zero Award in 2023 for upcycling wood from demolition into mass timber products.
I'm hoping to add to the conversation a kind of material end of the dialogue on circularity. But we'll begin with some of the work that I was doing when I was doing my PhD a few years ago, looking at how to the sort of policy and infrastructure moves to enable more reuse of existing building components. So this slide is looking at how to generate better information as a starting point. So carrying out a pre-demolition audit, but not having that sitting in an isolated way in a PDF, but instead being submitted to planning and then collated into some overall map, which it's not a map of everything in the existing building stock, but it's a map of the most pertinent information because these are the materials that are soon to emerge from demolition. Which then, once it's visible and mapped in that way, gives you the ability to leverage all the creativity and community of urban designers who know all of the specific requirements of their clients. So instead of an auditor trying to anticipate what's reusable and what isn't, you use this this collective intelligence. That can then lead into either direct reuse from one site to another, but probably more likely at scale, a third-party upcycler or someone doing repurposing or some kind of value add, which enables the end user to have the confidence in the quality and the timely quantity of materials getting to the new construction site. And then the system can have a kind of feedback loop so that it's learning over time and becoming more intelligent. So to sort of sketch that out as an overall way to stimulate a reuse market, I think I've talked there about policy to drive better information about materials and feed that into a digital infrastructure. It's also fired up. The system is incentivized through policy that drives more reuse. For instance, by having separate reuse targets to recycling at the end of the supply end, as well as the demand end, reusable content as well, reused content as well as recycled content. But importantly and crucially, I think, new material technologies and enterprises at the middle who really make this engine turn over. So that's where the example of UKCLT comes in. We've set up UKCLT with a view to commercialization of the research that we've been doing. which is quite simple, taking secondary timber, so timber coming out of demolition, and turning it into, using it as feedstock for mass timber. So what we're calling cross-laminated secondary timber and glue-laminated secondary timber. So this is the kind of schematic of what that looks like. So there's vast quantities of timber in our existing building stock, more than in forests planted for timber generation in the UK. Diverting it away from current waste management, which is all about chipping it, some recycling into low quality products, and a majority of incineration, and instead into a more local remanufacturing industry. So therefore creating jobs locally, as well as reducing the distances that mass timber would have to be transported from European manufacturers, or displacing other structural materials with higher impacts. And preferably doing that with a product design which enables future disassembly, so that the grey dashed line on the inside indicates those same components coming out of a building being repaired, improved, upgraded, and used again. And the impact there is all about life cycle of timber, because the longer you can make it keep timber in use, the longer it continues to sequester carbon. So we've been doing this for a little while. We made the first prototype back in 2016, and we've been doing the background science, publishing papers that do some structural testing of its performance, with overall pretty good results. We set up UKCLT a couple of years ago now, to, as I said, for the idea of commercializing this in the future. Just to give you a flavor of what we're working on now, this is a current project that we're taking the material out of the sort of world of material science and into the world of products. So it's being used as the components of a porter cabin module. So we're building this at the moment. In the middle is some of the timber feedstock that we've gathered and denailed, sorted, ready for finger jointing. And then on the right, that's yesterday, some fresh glulam coming back from where it's been pressed. So that's my introduction, and I'll hand back. Thanks.
Great, thank you. That's really, really interesting. Just wanted to ask about, you have all these sites to improve the quality of the timber before it's being reused. In a city like London, where space is such a challenge, do we need to see a shift in policy to support these spaces, or how can we bring about those spaces in a city?
Yeah, I think it's a really good point, and one of the biggest challenges for any sort of business working in this way, in a sort of space hungry way. I think there is increasing interest from local authorities in trying to get sites that enable these kind of circular supply chains. But I think that would probably be a first step of gathering and sorting materials, so that then for something like UKCLT or other specialists that are going to use a lot more space, would be further out of town. But definitely something that needs to be supported in policy. Yeah,
for sure. Okay, and then lastly, we'll pass over to Julia Barfield. So Julia is an architect and co-founding partner of architecture practice Marks Barfield Architects, which was founded in 1989. The studio's award-winning projects include the iconic London Eye and the British Airways I360 in Brighton, have earned Barfield an MBE. So their practice focuses on sustainable urban development and retrofitting, which has won over 100 awards. And Julia was also involved in the urban mining Tondo that we're going to hear about a bit later on. Thank you, and over to you, Julia.
Okay, can you hear me?
Yeah.
Okay, great. Well, I mean, all really, really interesting presentations. And I think my contribution will be that, you know, as a practice, we're trying to kind of put some of this into practice. We've got a very diverse portfolio, but in the last 5 years or so, we've been completely redirecting the practice to become ultimately regenerative. And as I was saying, you know, the percentages on the left, I think everyone probably is very familiar with them, but the one that always gets me is the 62% of waste generated by the construction industry. And, you know, the need to turn that around somehow. So we've been concentrating on retrofit and the circular economy. And this was an image that we produced recently to kind of show some of the projects that we've been working on. I'm not going to dwell on this at the moment. I'm going to come back to it. So very much moving to the, you know, has been talked about, mining the Anthropocene, moving from linear to circular, and focusing on retrofit. And this is a practical project that we've been trying to test these processes out on. It's in Baker Street, and we started doing this about 2 years ago. And you know, the idea was because it was a building where it had recently had a retrofit, we were just trying to keep as many of the materials as possible on site, ideally, and then if not that, then move them to somewhere where they could be used by others. And this is the kind of methodology we used. We started off by having a detailed material audit and a condition survey. We wrote a materials inventory, and then tried to identify routes to reuse, as I said, keeping as much as possible on site as possible. And then we developed also material passports. I mean, this was a retrofit project, so we kind of worked with ORMS and the Material Passport Working Group to develop this. And we also developed a kind of methodology about material reuse pathways. So it was looking at a particular material and then seeing, you know, does it need repair? You know, does this need to happen off-site? Does it need a survey or warranty? And, you know, there was a kind of yes/no matrix here, which then took us down to whether it was actually worth keeping the material or not. And we developed this whole, for all the materials, we developed this kind of pathway and methodology. And then we also developed the material passports that we tried to make as kind of simple as possible. It's just in Excel format and includes information on the refurbishment requirements, the history and maintenance, and previous works. I mean, we just so much of the vital information was lost previously, even though that building is only a recent building. It's only 20 years old. There was so much lost that we just kind of wanted to try and make sure that we could put that right in the future. So then this kind of shows really the key, the success stories on the project. So we saved all of the raised floors. I mean, that's a kind of easy win. I think it's been commonly known now that it's an easy win. And it was a considerable carbon saving, but also a cost saving. And the kind of more unusual one was the internal fire doors. So we actually managed to save all of the internal fire doors. I mean, this was quite complicated because we had to go and make sure they were recertified. But I think we kind of showed that it's possible. And here again, there was the carbon saving, but also the cost saving. And in terms of, you know, it did take quite a lot of time up front. But what I would say about that is that, you know, if we, for instance, had been designing new doors, we would have had to, at stage 4, we'd had to do detailed drawings of the doors that we didn't have to do. So even though there was an upfront, it took longer, it would actually save time further along in the process. And this is obviously the first time we'd done it, so, you know, we learned lessons and probably be more efficient next time. But the other things we managed to reuse was all of the concrete pavers, the HM timber fascias, and so on and so forth. And so coming back to the Tondo, so this is the Baker Street building, and what we were doing is, of course, using as much possible on site, but then we actually stored some of the materials to use on a host building. So the the 22 Baker Street became the donor building, and then we had a project that we were working on in Stockwell that became the host, the host building, and this was the in a nature garden, and it was a project for a forest school nursery and the nature garden in Stockwell. And what we're trying to do is build it entirely out of reused material, so that we'd set ourselves that as a kind of goal. And this is the kind of methodology that we developed for reuse, looking at the brief, looking at gathering the materials from all different places. You can see the picture of all the materials here. So these, for instance, are stone blocks that came from 22 Baker Street. We also had contact with a CLT company that did offsite housing, and we got a lot of the green panels that you see in the drawing on the right was actually coming from the CLT company. They were surplus to their needs, and they offered them to us. But what a major problem that we discovered, and that I think is a kind of major barrier to reuse, is the fact that we designed the building based on the materials that we were promised, but then we had nowhere to store them. So, and then subsequently the company went bust. So then we had to spend a huge amount of time trying to kind of recover the material, which we eventually did. And they're now sitting in a car park in Newham. But it just illustrated a problem that, you know, the timings for, you know, knowing when a material becomes available, and then the time of them being used in another building, it's going to be, I mean, maybe eventually it'll be possible to align that, but I think in the short term at least, it's going to be needed to have material stores. So this just shows some of the other elements that we found. I mean, we actually went to a project in the city that was being demolished, and we've kind of picked lots of the materials there that we could reuse. And there was also a whole pavilion that was being demolished. So we kind of said, well, we'll have that. And we managed to persuade the demolition contractor not to demolish it, but to deconstruct it. And that's what's been done. And it's now actually sitting in one of the other sites that the Oasis, our client, has. So it's been quite a journey. But I mean, we've learned a hell of a lot. And I think this is one of the things that we've learned, is that, you know, there's a lot of, I think, digital materials stores that are being developed, and all really needed. But I don't think we can ever get away from the fact that we also need physical material stores. And of course, we also need to reuse natural materials as well. So this is the kind of a diagram that shows how that process might be done. And in fact, we're talking to a strip out contractor that we met when we were doing the Baker Street job, who's wanting to set up a material store in near Tobacco Dock, and we're trying to do that at the moment. And this is just a slide that shows, you know, in the journey that we've taken over the last 2 years, we've been talking and trying to collaborate with so many different people. You know, I think there is a kind of community of people who are trying to do this for real now. And I think we just need to collaborate more and share knowledge more. And so that's me. Thank you.
Thanks, Julia. That was super interesting. And yeah, I agree with you. You need the physical stores and the digital to make everything work together. This was actually a question that came up in our last panel conversation, but with Lenair Architects, which you just showed on your last screen. And the question came from the
I visited their office.
Oh, yeah. Cool projects they do.
Brilliant. So. They are just so amazing. Anyway.
But yeah, it was an audience question we didn't have time for. And I wondered if the same problem came up in your projects about warrantying reused materials. Did you find any challenges with that in the host building?
Yes, well, no, of course. Yes, no, there are. Of course, there's challenges. But there are, I think what we discovered is that there's ways to get over them. And with the fire doors, particularly because they were fire doors, we just kept them in place. I mean, if we were taking them out of the building and then had to move them to another building, that would have been another level of complication. But because we were keeping them in place, we did get fire experts to come, and we looked at every single door individually, and were able to upgrade them where needed, and then get them recertified by a specialist fire certification company. But yeah, I mean, that is one of the barriers, and we just by doing all of this, we can kind of discover how to do it in the future better.
Yeah, for sure. So Annika and I had a couple of questions, but I was running a little bit low on time, and we've got lots of great audience questions as well. So we'll just start with one. So we've heard a lot about different tracking material flows and material mapping. And we just wondered if you thought that there should be a regulatory body ensuring the consistency throughout the market. And maybe if we start with Nico on this one, please.
Yeah, I think it's key, especially if you want to compete with virgin linear materials. There needs to be regulation to make sure that quality can be guaranteed, and also constructors can count on the quality of the materials they're using. So for sure.
I don't know how we can drive this to come about more. Maybe Colin, you also mentioned a bit about policy. If we to give that over to you as well.
Well, a whole new regulatory body to help to manage reuse specifically feels to me like it's more about tweaking the mechanisms that we already have rather than introducing new bodies. But that example of fire door recertification specialists is a really good one. Like, we need those kinds of specialists for each of the different components that we're aiming to reuse, and for that process to be a much more common one. Maybe there's some kind of regulation or standards that picks out the commonalities between all of these processes. But I think there are probably quite specific challenges around safety that have to be managed for each different product type that we're looking at.
Yeah, for sure. I think it's all these things exist, and all the different standards, and to make it all work in unison, there's so many different things going on within the industry.
We also have a second question coming from us, and then we will jump over to the audience ones. Basically, we were wondering what would be like the next step, or how could we increase the impact of the reuse market that we already have, and how can we bring it to the next level? Maybe one of you who feels like having a good answer can jump on that.
I don't know if there's like one next step. I feel like, especially like with the stuff that Julia just presented, like we are at the start of the early adopters. We're not quite at the scale yet. We've not kind of proven it enough. So I think what we need is a few more people like doing it well and shouting about it. We're not going to convince everybody to do this unless we've got a lot of precedence, unfortunately. So I think, unfortunately, that's we just need to do more of the hard stuff first. And there's a lot of supporting things that will help make it easier once there's a groundswell.
Yeah, absolutely. We feel like everyone is also, like, when we are talking to clients, always like pilot projects are needed to explain a bit what's happening and how it can look like, or where potentials are. So yeah, I think that's definitely a good point. Anyone else wants to?
I think
maybe Pippa and Julia, yeah. Thanks.
Yeah, I think the last 2 points that were covered by Julia, I really like them because that's what we are trying to do, which is the first, she pointed that actually they end up saving money. If we do more cases that we prove that there is a business benefit, not only the impactful one, that is where people start adopting it. Actually, most of our clients are seeing competitive business models. I mean, and that is one of the things that I think it needed at scale. That as it was saying, like we share not only the story about how much waste, but how business it makes business sense. And the second, extreme collaboration. I do love that how many partners you have in there, and I think that is the next step. Like this, the industry and the value chains were built over so many years in a linear way. Now we do need to have this extreme collaboration to be able to collaborate each other, each one with their parts, to actually build this new value chain, which let's call it circular. But extreme collaboration and business proposition, I think, are the 2 keys that we should all try to seek for.
Yeah, that's a very good point. I think, Julia, you also raised your hand.
Yeah, no, I mean, I would totally agree with that and what Andrea said as well. But I can't help thinking also that it might help to have some kind of legislation, maybe not immediately, but down the line, so that everyone knew it was coming, that, you know, X percentage of, you know, a building has got, you know, you've got to use X percentage of reused materials. Just, I think that will focus people's mind and get people to take it seriously. I mean, I'm part of Architects Declare, and we did a policy document recently called Building Blocks, where we were proposing that this was one of the things that was introduced in legislation.
Thank you very much. I think then we will jump over to some of the audience questions. I think we won't be able to go through all of them. Apologies for that, but I think the input we had was very valuable. So maybe one question that was coming from Stephen, he was asking, like, should reuse of materials be part of the town planning and strategic planning system? So yeah, you can't get permission to build unless you have identified and secured where you reused materials are to come from. Any takers for that, maybe?
Anybody mind if I jump in first? Okay.
Sure.
Yeah, I think it's a useful point, and I think that's that is in a small way already part of the planning system in London now. Developments need to do a circular economy statement prior to planning, and it's not as strict as what's suggested in the question. It's not like they have to demonstrate where they're going to get all of their materials, but they do have to demonstrate that they have thought about the whole life of that development. Waste if there's anything to do with demolition, waste during construction, waste throughout life, and at end of life, and it's waste in the broadest sense. And I think that is one of the things that has helped catalyze an interest in this agenda over the past few years, that even though the planning policy is not, it's not like what Julia said, it's not a specific target on a percentage, and it's not as rigorous as what's suggested. Even the light policy has already meant there's a lot more people interested in this topic. So I think policy is good. It does help set direction. I don't think we can just rely on it. It's policy is only ever going to bring up the extreme laggards. It's not going to accelerate the forefront of the industry.
Maybe we can add on like the last question that came in the chat, because that works quite well with the one we had right now, because it was about beyond the regulation and legislation, how can the public sector be more proactive to ensure the reuse market is being pushed forward. That's not like by word what was in the chat, but maybe we can add that to the question. I think, Nico, yeah, you had your hand up.
Yeah, I can reply. I do think so. When we talk about circular material use, the playing field is not really level. So it is in the current system a lot harder. It's more expensive, and there were some suggestions within the chat to also tax virgin materials or have a tax deduction on circular materials. And I do think policymakers and policy play a huge role in making this playing field a lot more level. At the other hand, we also have to realize that we don't have enough secondary materials to replace all virgin materials. So saying you can only construct if you can harvest your material, that means that, well, we might have some social issues down the line, which is, I think, also very important to consider, that circularity is not in a vacuum. It's part of a larger discussion where social factors also should be taken into consideration. So I think private parties can really scale the circular economy, but I think public or governments do play a crucial role in making the playing field more level to give circularity a good standing.
Yeah.
Another thing local authorities or city authorities can do is to drive demand for these materials through public procurement. So I think as well as the sort of policy setting agenda, there's a significant spend there that could be one of the ways that we give more confidence to new enterprises that there is going to be demand.
And I think the question is also around it's a bit around the governance and the standardization as well, isn't it? And I think there is definitely, and it mentions interoperability. I think there is definitely going to need to be standardization around interoperability of this data. At a product level, it's going to come through Europe probably soonest. And I think that is, there's a question around what scale is it? And I think for the product level, European is probably the right scale, because we don't just use products here or create products here. It is a global marketplace. When we're coming down to the asset level, it depends who's receiving the value. If it's the client that's receiving the value, then we don't necessarily need standardization on that. But if the value is for these larger, more strategic decisions, then somebody needs to define what it is that they want to collect and at what scale, and then that's will define those kind of requirements. I think from a developer perspective, at the moment, that would be done at a local authority level in the UK, and that's actually really tricky, because that means they've got completely different requirements on different developments in different locations. So actually, from a developer perspective, it would probably be ideal if that was a national decision, because it means they know what they've got to do and it's the same across all of their developments.
Yeah, very good points. I mean, maybe we then jump to the next question that was asked by Julian in the chat about what would be required to make more material recovery cost effective. Is there like a carbon price or more cost effective recovery methods, or also economies of scale? Anyone who wants to say something about that?
Well, definitely what we have seen is that there is like a short term and a longer term. So normally circular business models, what we have seen, they typically take a little time to scale, and hence the cost, they cannot be cost effective at the first time you do it. However, I do not believe, we have proven it. And actually the Circular Building Coalition that it was presented, there is a lot of examples that companies are doing it at the scale in a cost effective. The only thing is, of course, the transition takes time. You need to change the tools, or companies, manufacturers and building owners, property, they need to change the way of working. And that typically it's like any other, let's say, change you do. However, once it's incorporated and the learning curve is there, we have proven here in Denmark, it's being done at business cost effective without any regulatory taxation or anything, just business, pure business. However, of course, the time spectrum is so important, because again, it's not going to happen in the first time. Julia explained it, we only saw it once we actually finished the project. So that is so important that for everybody that it's hearing, is that it's so difficult to compete one-on-one if you go to almost a marketplace and buy a new product or a reused product, because the cost of making this material passport, learning, everything, it doesn't happen at this first time. It needs to have these unities of scale. And I think that is what we have proven. Definitely when we started supply, it wasn't that easy to be cost competitive, but we have gotten there. I think we are there already, or at least much more competitive than before. Just in this panel, they presented already how many cases that it's competitive cost-wise.
I think from UK CLT perspective, yeah, really, it's very much about scale. Like there's no way today we can get anything anywhere near delivering CLT at the price that you could get it from the mass producers. But the business opportunity is that over time we can become both wood waste managers. So we take money from at the supply end as well as selling product, and between those two, maybe also carbon carbon storage income as well. We have to try and do the whole of the process. So that's the basic equation of how to, like, whether a circular material business can make its numbers balance. And yeah, it looks challenging. It would really help to have, like, all the stuff that's been spoken about, negative externalities priced in, regulation that drives more demand, so that a circular product becomes more attractive to the market than a non-circular one. But in the meantime, I think it's the way I see this, the sort of case of this business, this business as an example, is to start trying to do it and see how far off viable it is, so that's part of the evidence base that helps to make the case for this, for policy changes.
Yeah, I think these are very good points. And I think what we always hear, like also from your answers and also what we heard in the last discussion, was always this redefinition of value, like defining the value of materials differently that we've done it in the past. So that's maybe also a big topic we need to focus on. Maybe one last question from the audience. I think that's quite a nice one, because it's also a bit like future thinking, like how do we prevent a repeat of what is already happening with buildings being owned not for use but for their value of international investors. So if large investors buy and keep empty buildings in order to mine them at some point, then rather than use them for other usages, how can we prevent that? Maybe also quite a difficult question, I would say, but maybe someone can take that one.
It would actually definitely doesn't solve everything, but one of the problems that we keep facing is that the old buildings, there is no data around them. That is something that we hear very often. So you need to redata them, or like basically go again and figure out what you actually put in the past in there. In today's, we are trying to solve it by, wherever we do a project, we don't only do the digital twin of whatever it was there and then it got renovated or deconstructed, but we do the digital twin of the new one, of whatever stayed there. So at least whenever you do a further renovation or a future reconstruction, you don't need any more to do this. So you already have the data, kind of the transparency around it. And I think that is a very big challenge, because keeping it for 10, 15 years can be expensive, right? But at least if the data is there and we know what we have already for everything that we build, at least you kind of take the first step towards in the future being able to solve that. So having a digitalized or having a proper material bank of everything that it is in there at least solves the first step, I would say.
Yeah, I think I agree. And I also think it would be a very nice situation, on also be a bad situation to be in, but I think if we were actually valuing the materials more than we're valuing the function that the buildings provided, like that is such a massive swing from where we are today that I think we can solve that if we ever get close. But I think for now, I think what we're trying to do through all of these, you know, data points and platforms and the analysis that Metabolic showed, Nico showed, is that there is some value at all. It's not waste, and it shouldn't be wasted. And this is the first part of the education piece.
I mean, one thing that we found, because, you know, as architects, for the first time ever in my career, I'm talking to demolition contractors. I've never done that before. And it's really interesting. And I've discovered that they really care. You know, we've been talking to two particular companies, and you know, one of the companies, they spend £8 million a year on waste disposal. Now, obviously, for them, it's a really good thing to reduce that figure. You know, so, but how do you get the business plan to work that in creating material store that will be, you know, commercially viable? So that's the kind of conundrum. I think we're so much at the beginning of all of this that it's you know, we need to kind of dive in, but it's risky.
Okay, thank you very much all for your answers. I think we are coming to an end with this city conversation, although we still have some more questions. I mean, we will try to answer them maybe after the presentation and come back to everyone. We will also publish the video, the recording of today, and also a short summary of all the presentations and the discussion we had on the on the Happold Foundation homepage. And yeah, we are happy that so many of you came, and we thought it was a very interesting discussion that definitely should continue, because as we heard, yeah, we still have a lot to do to get a bit more circular in the build construction industry. Yeah, and so thank you very much for coming, and maybe over to you, Andrew, to wrap it up.
Thank you to you and Kitty for chairing it. I was going to say the same, that there are some very specific questions out there that we will try and match up with the people who they're aimed at. But a big thank you from me to the panelists. That was really stimulating. I've just got lots of questions buzzing in my head, like how does AI fill in all the gaps in such a complex thing? So, and I thought the illustrations were really enlightening. So I've had a really interesting time, and thank you for all of you, and to the audience for your contribution also.